Arrays. Arrays are created by ordered copies, in a circle, or at angles of a given rectangular grid. Arrays offer a comprehensive selection of options, and we will now examine each of them. Let's get acquainted. Based on these three elements, we will create a rectangular array. Select the elements, confirm, and then we see the following options: associative, base point, count, spacing, columns, rows, levels, and exit. Let's start with associative. This parameter allows for quick modifications across the entire array, thanks to the established link between the elements, as the elements of an associative array are perceived as a single object. Let's enable associativity. Next, the base point. We'll set the base point at the center of the circle and enter a column count of 5. Confirm the number of rows, let it be 4. Next, the interval between columns. We'll round it to 25,000. And, accordingly, we'll set the distance between rows also to 25,000. The level will be 1. That's all. This is how an array looks, consisting of 4 rows and 5 columns, with a set interval between columns and rows. After we'll select the array, we see that it's a single object, having its own set of editing grips. Hovering over each of them brings up a contextual menu. We can stretch and add new columns, add new rows, move by grabbing the base point, and change the interval between columns and rows. You can do the same using the Properties toolbar. All parameters are editable. In addition, we can edit the array through the reference editor by double-clicking on the array, or waiting for the context menu to open, then going into the source option, and making changes directly in those elements, which will be adopted by the entire array after saving. For instance, let's change the circle's diameter. Instead of a rectangle, let's draw any polyline. On the polygon, let's stretch one of the vertices. After which we can save the changes. We can remove from the set, or we can alternatively add to the set. Let's save the changes. In this way, we can edit the array, change its appearance, as well as add or remove new elements from the set. Next, after the rectangular array is the polar array. Its essence is to evenly create copies of objects in a polar array, around the central point. In this case, the central point will be the center of the circle. We'll use the polar array command, and we have already selected the object beforehand, then confirm the action by pressing Enter, and specify the central point. Now, a preliminary view of the array is displayed on the screen, based on the current values of its parameters. With this context menu, we can configure this array. Also, after finishing the command, these options will be available on the Properties toolbar. You can see them now too. Let's finish the command, select the array, and see a series of editing grips. The central editing grip is responsible for moving the array. The triangular grip, as you can see, can change the angle between elements. And the square grip opens the next list of options, which we can control. We can stretch the radius, change the number of rows, number of levels, number of elements, and fill angle. In the same way, we can create an array outside of the circle, specify the central point, after which a new array is created, with the same options for editing. Now let's get acquainted with the array by path. To create it, we'll construct a line based on which the array creation will take place, then draw a circle. After that, select the array by path. Let's select the object and the curved line. Confirm. By default, the array will look as follows. It has the same editing options. We can go to the source and, accordingly, modify its internal component, specify the base point, distance between rows, levels, and alignment of elements. Everything here is already perfectly aligned, so this command won't work. Let's enter 2 for the number of rows. The distance between the rows can remain as default. After selection, you can also edit through the Properties function panel and, respectively, the editing grips. Array by path can be created for any curved line, for instance, spline, polyline, and so on. Next in line are chamfer and fillet. Let's work with each of them using a randomly drawn rectangle as an example. Fillet rounds the corners. Let's leave the insert arc as fillet parameter unchanged. The preview shows how each parameter will look and the type of cut. We'll set the radius to 500. OK. Select the first and second object for filleting. Now let's use chamfer. Chamfer, on the other hand, cuts off the corner. Here we'll change the length to 500. Keep the symmetric parameter. And trim full. OK. Also, in the dialog box, you can adjust dimensions for the further work with corners. Let's now draw another rectangle. We've already enabled the dimensions, so let's click OK. The command will automatically measure this chamfer. Here you can immediately see that chamfer by length and angle was chosen. If it's a fillet, the radius will be indicated. Fillet. Dimensions. OK. This is how these two commands work. You can also set up chamfer and fillet while drawing a rectangle. Chamfer and fillet. And the parameters you enter in the command line will be applied when creating future rectangles. For example, chamfer 200, the second chamfer angle is also 200. Until you re-enter a value of 0 for the first chamfer of the rectangle and, respectively, for the second, the rectangle will be constructed with the specified parameters. The next 3 commands we will look at there are delete, explode, and join. Let's start with explode. This command allows you to break complex objects, such as polyline, into separate constituent elements. For example, if it's a block, it will be divided into its constituent object. If it's multi-line text, then into separate lines. This polyline, or more precisely, this rectangle made of body lines, can easily be broken down into individual segments using the explode command. The next command is delete. This command is equivalent to the delete key action. After selecting the object to be deleted, you will need to confirm the command. It's most convenient to use either trim or the delete key. The next command is offset. This command allows you to create similar objects at a specified distance from the original objects. For this, you need to specify the offset distance, confirm. Select the object, then specify the side for the offset. This command is cyclical, so you can continue creating similar objects. The command can be interrupted with escape. That's all, in general. Now let's move on to editing polylines and splines. Arbitrarily draw a polyline, then open additional tools from the Modify group. Edit polylines. Select the object and choose an option. Half of these options are already known to you. It's worth noting that we can immediately convert from a polyline to a spline. If we want to revert from a spline back to a polyline, we need to select the curve. We can also fit the polyline, set the width, and more. Let's try an example with a spline. Edit polylines, and edit splines. Select with options Edit splines, confirm, and see similar options as when editing a spline. Similarly, we can convert a spline into a polyline. This can be seen on the Properties toolbar, or we can revert it back to a spline. These two commands are rarely used, so there's no point in dwelling on them too much. Let's move on. The Align command moves and rotates an object in such a way to align it with another object. Let's arbitrarily create a rectangle and a line by which we'll align it. Call the Align command, then you need to select the object. That can be aligned along this line, and specify two pairs of points. The first pair of points will set the base alignment point. The second pair of points determines the rotation angle of the object being aligned. Confirm. Scale object to alignment points. For clarity, let's press No. And we see that the rectangle is aligned by this line. If we had used scaling, the distance between the first and second designated points would be used as the reference length for scaling. Now let's tackle the last tool, break. In nanoCAD, there are two types of breaks. The first is breaking an object at 2 points. In this case, the part of the object located between the 2 points will be deleted. And the second option is breaking an object at a point. To perform this operation, the same point can be specified as the first and second points. Let's look at an example of breaking an object at 2 points. In this case, the selection of the object will be counted from this click. Meaning, this will be the first point that we specify on the polygon. And the second point, respectively. We can also use the first point option. Select the object, first point, and specify the first point, then the second break point. So, it can be done with options, or without options, the result will be same. And now, the second option, a break at the point. Let's select the object. And then you need to specify the break point. Let's arbitrarily specify it here. After highlighting, we can see that the polygon is no longer a single polyline. This method also divides lines, arcs, polylines, splines into two parts.